Hi children, good morning. Welcome back my channel. Today we are discussing about some more properties on rational numbers. Okay. In previous video, second video, we are discussing about closure property and a commutative property and associative property. Closure means if you are taking any two rational numbers, their sum is also a rational number, then it is said to be a closure property. Commutative means we can add any two rational numbers anyway. Suppose a by b plus c by d, otherwise c by d plus a by b, both are the same result. We can get the same result. Then only we can say that the rational number set is satisfy the commutative property under addition. Suppose you can keep here into, it is a multiplication, minus under subtraction, divided under division. Okay, four operations, the rational numbers set satisfy the commutative, closure, associative properties only. Associative means suppose we can take any three rational numbers a by b plus c by d. First of all we can add a by b c by d, then only we can add e by f, which is equals to, suppose first of all we can add it by c by d plus c by f, then after that we can add a by b, we can get the same result. So that's why the rational number set satisfy the associative property. These are the formulas. Okay, how to recognize the formulas means like that only. A by b plus c by d is equal to abbreviations, formula, closure, commutative and associative. Now we are discussing fourth property, that is identity property. What is identity means, suppose a by b is an irrational number or 0 is also a rational number, their sum, suppose a by b plus 0, otherwise 0 plus a by b, which is equals to a by b only, itself only. So ఇది ఇంకా క్లియర్గా అర్థం కావడానికి యూ కెన్ టేక్ న్యాచురల్ నెంబర్. సపోజ్ 2 ఈజ్ ఏ న్యాచురల్ నెంబర్, 2 and okay, suppose 2 is a integer, natural number not integer. Suppose 2 plus 0 is equal to 0 plus 2. Why? Because here 0 is not a natural number, so that's here we can take 2 and 0. 2 is a integer, it is a natural number also, but 0 is a integer but not a natural number set. So that's why the natural number set does not satisfy the identity property under addition. But integer set we can take 0 also integer only, so that's why 2 plus 0 is equal to 0 plus 2 is equal to itself 2 only. So that's why integer set is satisfy the identity property under addition. So same like that only, a by b is a rational number, 0 is any number. Suppose a by b plus 0 is equal to 0 plus a by b is equal to a by b, then it is said to be a identity property under addition. Suppose we can take a by b and 1. 1 is also a rational number. A by b into 1 is equal to 1 into a by b is equal to a by b only. In both cases, observe that the result will be the itself only. What is the difference? But only binary operation can change. Okay. Suppose in addition 0 can be added to any rational number, the value did not change. So that's why 0 is called additive identity element. 0 is called additive identity element. Here a by b is multiplied by 1 and any rational number is multiplied by 1, the value did not change. So that's why here 1 is called additive identity under multiplication. Okay, here operation also must. 0 means under addition, 1 means under multiplication. 0 and 1 are the identity elements only. Okay, divided also same, 1, subtraction also same, like that only. A by b minus 0 is equal to 0 minus a by b is equal to both same result. No, this is plus a by b minus a by b. So that's why under subtraction the rational number set does not satisfy the identity property. Under division, a by b divided 1 divided a by b, both are equal? No, a by b divided 1 means a by b only. 1 divided by a by b by a, both are not equal. So that's why under division, the rational number set does not satisfy the identity property. The rational number set satisfy the identity property under addition and multiplication only. Under addition and only two binary operations. But above properties, closure, commutative, associative, they are satisfy the all binary operations under addition, subtraction, multiplication, division. But identity property only satisfy under addition and multiplication. Why? Because here we can prove a by b is not equal to minus a by b. A by b is not equal to b by a. So that's why does not satisfy the identity property under subtraction and division. Okay. Next, fifth property, multiplicative inverse or additive inverse. Additive inverse property. Suppose first of all we can discuss additive inverse. After that we can discuss about multiplicative inverse. Additive inverse. Additive inverse means what is the additive inverse of 2? Minus 2 only. What is the additive inverse of 3 by 7? Minus 3 by 7. So like that only. If you are taking a by b, its additive inverse is minus a by b. Their sum must be equal to 0. Suppose we can take minus a by b, its additive inverse is plus a by b. Their sum is also a 0. Okay. The number, and suppose a is a integer, a plus of minus a is equal to minus a of plus a is equal to 0 only. So that's why the rational number set satisfy the inverse property under addition. Suppose 2 by 3 plus of additive inverse minus 2 by 3, which is equal. Suppose you can take minus 3 by 3, which additive inverse is 2 by 3. Their sum must be equal to 0. So that's why rational number set satisfy the inverse property under addition. Under multiplication, that is called as multiplicative inverse. Multiplicative inverse. Multiplicative inverse. Suppose you can take any rational number a by b. A by b. Its multiplicative inverse is b by a. Suppose you can take 2 by 3, multiplicative inverse is 3 by 2. Suppose minus 2 by 3, it is minus 3 by 2 only. Symbol does not change here. Only you can interchange the fraction. Numerator becomes to denominator, denominator becomes to numerator. Okay. Suppose multiplicative inverse, a by b into b by a. Result which is equals to 1. Suppose we can take b by a, it is multiplicative inverse is a by b. There becomes to 1. Okay. Their product is 1. So that's why the rational number set satisfy the multiplicative inverse property under multiplication. Multiplicative అంటున్నాం కూడా multiplication లోనే అంటే so that's why the rational number set satisfy the identity property in both binary operations addition and multiplication. What are the abbreviations? A by b into b by a is equal to b by a into a by b is equal to 1. Suppose okay, a, its multiplicative inverse is 1 by a. Suppose you can take 1 by a, its multiplicative inverse is a. So their result becomes to 1. That is also called as multiplicative inverse property. Okay. These are the 5 properties. The rational number set satisfy the 5 properties. Okay. What are they? See, listen. Closure, commutative, associative, identity, inverse. These are the 5 properties. Okay. Every number set holds these 5 properties. Okay. Some more properties also there. First of all, we will learn about these 5 properties. Suppose natural number set q under addition. Rational number set no under addition, under subtraction, under multiplication, division, under division, under addition, it satisfies all the properties. Under multiplication, it satisfies all the properties. So observe that cleanly. Subtraction, it satisfies the closure, commutative, associative. Division also closure, commutative, associative. Identity does not satisfy the identity property. Why? Because a by b is not equal to minus b by a. So that's why under subtraction does not satisfy the identity property. Okay. Inverse, suppose you can take a inverse property under subtraction. Inverse, what is inverse? Suppose you can take a by b, its inverse is minus a by b, their sum is also a 0. That is called inverse property under addition. But subtraction, suppose a by b, its additive inverse is minus a by b, their subtraction means a by b minus into minus plus a by b, which is equals to 2a by b, 2a by b, but not equal to 0. So that's why the rational number set does not satisfy the inverse property inverse property under subtraction. Okay. Same division also like that only. Division also like that only. Okay. These are the 5 properties of rational numbers. 5 properties of rational numbers. Okay. Next video discussing about some more properties. Thank you.